Texas A&M University of Kingsville and the Cesar Clayburgh Wildlife Research Institute. It's a mouthful. I'll be talking to you today about the effects of prescribed burning on butterfly populations in South Texas. We'll skip a couple of these. So we're at this fire conference. If you look around at some of the vendor booths, you'll notice that there's a lot of stuff about pollinators, and that's because pollinators are really important. Depending on where you are in the world, up to 95% of plants may require pollinators, and over 67% of flowering plants actually require insects as pollinators. I can talk about it all day about how great they are, but that's going to keep us here all day. But recently studies are coming out showing that there's long-term declines in arthropod biomass. So there were studies in Germany, the Netherlands, Ohio. These are long-term studies that are showing that we're seeing a decline in pollinator or insects. So what do? We should look for ways to help manage their habitat. And I don't really have to emphasize the benefits of burning to a burning conference, but I'll kind of talk about the benefits of burning in South Texas in regards to butterflies and other pollinators. So we know that with our grasslands, burning will remove that old vegetation or that dormant vegetation, and that can encourage more forb growth. So forbs may increase after vegetation, or that vegetation has been removed. It can promote grass growth, especially when you get some good rainfall immediately following a burn. And we know that our butterflies are using forbs for host plants, and there is recent evidence showing that they're actually also using these grasses as well. Post-burn, we do see that there is an increase in protein content in grass. The phase 1 of this study saw that there was an increased elevated protein content for 90 days post-burn. And we know that butterflies like to lay their eggs on new, fresh growth because it's easier for the caterpillars to eat. So there could be something of that as well. So the objective of this study is to determine the effects of prescribed burning on butterfly populations, hence the name of the title. Our study area is located at the East Foundation's El Sauz Ranch, which is located in Willacy and Kennedy County, Texas. It's in the coastal prairies and marshes ecoregion. It's really hard to see, but there's a tiny little star, I can't point here. There's a tiny little star here that's located where that ranch is. It's about 27,000 acres. And it's owned and operated by the East Foundation, whose mission is to support wildlife conservation and other public benefits of ranching and private land stewardship. And they do this through outreach, education, and research. Okay, so this study first began burning in 2016. We have 16 burn plots ranging from 500 to 1,200 acres, and they're burned with different seasons, so winter and summer, and no burn control, and then different time return intervals, so long and short. So the short-term burn return time return interval is about 3 years, long-term is about 5. That doesn't quite work with our butterfly study, so we modified our treatment plots just to be season of burn and when they were last burned together, because our butterfly populations fluctuate so much. All right, so we have some average weather conditions for our burns. It's very hot for you guys up here in Nebraska, but our winter average temperature is 79.5 degrees Fahrenheit. And on summer, they decide to choose the hottest day possible, so on average it's about 94 degrees Fahrenheit. For ignition, what we normally do is we'll do black lines, so those are ignited with strip flanking fires, or backfires where Gulf cordgrass is present, and I'll pull up a picture of Gulf cordgrass in a second. Our main pasture is done with a flanking or a head fire, and we usually aim for a southeast wind, although that's not always necessary for this. Here's a quick little video, because you guys have not seen enough fire videos this week. But this is one of our burns that we've done. You can see our flanking fires. It'll be apparent next that are pulling the flames in. Looks really cool. Things are going great. We're having a good time. It's probably 100 degrees because it's South Texas. There's our black line our black post burn. And there we are saying, "Hey, good job." Okay, so for our butterfly transects, we have a little image way up in the top corner. I don't know if you guys can actually see my mouse or not. I can't see my mouse. But there are 100-meter by 10-meter bell transects that come together in the center of each plot to form a square array. Plots located closer to the coast have Gulf cord grass. So on the bottom right picture, you can see those big plants. Those are Gulf cord grass. They kind of dominate an area. The plant communities are a little bit different in those areas. So an extra array was placed in those 8 or 9 plots. And then we did monthly walking surveys to observe butterflies. They were recorded down to species, but for the purposes of our analysis, we used them to family, and butterflies' interactions with plants were recorded. I'm going to go real quick through this. So once again, we did monthly data on abundance, family richness, and Shannon's diversity. We used a linear mixed model with time since burn as repeated measures, and this was done on a log+1 transformation because it's count data to make it more evenly distributed. The nectaring activity that we'll get to after that was done using a generalized linear mixed model with log link, and we just compared season of burn, so summer, winter, and no burn. And lastly, our hotspot maps were done using butterfly abundance. This is a lot to look at, I apologize. So this is just looking at abundance in our winter versus summer. So we first looked at interaction between season, or time of year, so month, and treatment. We were able to go and survey for 24 months straight with the exception of 2.5 months due to flooding. So we first looked at that interaction. When there wasn't an interaction, we looked at each individual month. And so months that didn't have a significant difference, they're marked with an N at the bottom. I can't point and run. Anything that did have an interaction was marked with an asterisk or a star. And then the letters on the top indicate the differences. If they're similar letters, they're the same. Different letters, they're different in terms of averages. And you're going to see this through this slide and the next two, that there's no real rhyme or reason as to what's causing the differences in individual months. It's just probably the ephemeral nature of butterflies. I do have it marked in areas, let's see, richness. With where there's been a burn, we do see a drop that month, either that month up or the month after. There's a lower abundance in those treatments, but overall there's no real pattern between burn treatment and butterfly abundance, richness, or diversity, as you can see in these graphs. And I just said overall results. But in many cases, there was an interaction between time of year and treatment. And we know that things are going to change throughout the year. There are different butterflies that are prevalent in spring and fall versus summer or winter, and same with some plants. And once again, this was done on the log +1 scale. I'm going to go real fast with this, just to catch up. We created these hotspot maps using the topo to raster tool in ArcMaps. We basically took each month and butterfly family and abundance for the plot, used the point elevation as the type, and the raster calculator to create the months that we're looking at. So this is just done for spring and fall. Brighter colors, so the yellow, I do hope this is colorblind friendly, I apologize if it's not. So the brighter colors are higher abundance, the lower colors are lower abundance, and this is done March through May of 2020 and 2021, and September through November, once again 2020, 2021. We did not include the months that we would be burning. Once again, visually, there's not really a big pattern we see in those two lower plots. Those two lower plots, they seem to be a little bit cooler in a lot of our hotspot maps. So there's something going on there. We do see some warmer spots in the very northwest corner. That area has a lot of woody vegetation, but once again, no actual patterns. There were some interesting differences with individual families. So the Pierides, those little yellow and white butterflies you usually see flying around everywhere, those are Pierides. And you take a look at the light purple transects, which might be hard to see up there. you'll notice that the brighter colors are around those kinds of transects. So there's definitely something going on. Those are our cordgrass transects. So there's something happening with the Pieridaes and those, whereas we compare them with the Nymphalidae. So everyone's heard of the monarch butterfly. That's part of the Nymphalidae family. We're seeing more abundance around the non-cordgrass transects, those darker purple hotspots or transect areas. Ooh. Okay. So the mean number of nectaring butterflies did not differ between summer burn, winter burn, and non-burn treatments, but there were some individual differences. This is a lot. This is 24 months of data. So basically, when we were out there, any butterfly that we saw nectaring on a plant was recorded, and they were put into this bipartite network. And even then, that looks like a lot, but there wasn't really a lot of data that we could do a lot of analysis with. We only had enough data to look at 2 individual butterflies, but these are the connections of all of these butterflies made over the 24 months. We know that there is going to be difference seasonally due to when plants and butterflies are available or around, but we just wanted to kind of take a look at any patterns. Okay. So our butterflies, the blues, they were only identified down as a blue to genus because they can be really difficult to identify in flight. So there were a couple of plants that they interacted with or were nectaring on. The tooth-leaf croton and the soldier weed, the first and last, those seem to be preferred in summer burns over winter burn plots. And the scarlet pea and the Texas frog fruit seem to be preferred in the winter over summer. Whereas our queen butterflies, so those are your monarch lookalikes, there are only 2 species that they really seem to get enough data that we could analyze. The soldier weed, there was not a preference between summer or winter, but our mistflower, there was a preference for nectaring in winter burn plots over summer burn plots. This makes sense. Burden and all, they had a study done, I think in 2010 on Matagorda Island, Texas. They looked at season of burn on vegetation, and they saw that there was a reduction in frequency of mistflower 1 year post-summer burn. So that would make sense why we're seeing our queens nectaring on them in winter. Okay, so we have some future considerations. So there are other factors that may be playing an impact on our butterflies. That's not just season of burn. Is anybody familiar with what an oak moth is? Like 2 people. Awesome. So basically down in South Texas where it's all rangeland, there's areas of trees. They can be really small or really big, but they're these woody moths. They're clumps of trees. They're like the only real shade for ever. So we were seeing a lot of butterfly activity around that. We decided to analyze in the control plots if distance to moths had an impact on our butterfly abundance. And we compared that for the cordgrass plot or transects versus the non-cordgrass transects. There was a significant difference. The non-cordgrass transects, there wasn't an effect of distance to oak moths from transects, but there was in the cordgrass plot. So we saw that for every 50 meters away from the oak moths, there was a reduction in about 19.6% of butterfly abundance. So something's happening there. We haven't had a chance to look at distance to roads or water sources, but that would definitely be something to look at in the future to see how that's impacting butterflies. We also know that weather is a big impact on arthropods. We had 2.5 months we weren't even able to access our plots due to rain and flooding, so I wish we were able to analyze the precipitation. We did have a hurricane hit our plot. We were very lucky, or not lucky, I'm not sure, because we were able to analyze that. We didn't see a difference in a Category 1 hurricane directly before and directly after in terms of abundance, but we also did get to see an extreme freeze. I know that, in the 20s is not really cold for up here, but down in Texas, miserable. And so we had sustained temperatures in the low to mid-20s for a few days in February 2021. We compared the abundance of butterflies March through May of 2021 immediately after the freeze, and we compared it to the year before, March through May 2020, that didn't see a freeze. There was a 70% reduction in butterfly abundance. So we know that weather is impacting our butterflies as well. And lastly, there have been a lot of management recommendations for how to burn with arthropods. You want to make sure you're leaving areas of refugia, so these areas that aren't burned. You want to burn throughout different seasons and throughout different time return intervals. It could just be that our ranch burn plan actually has all of that, so our butterflies are able to easily come in and recolonize an area post-burn, and we might not be able to actually see an impact on that. So, I gotta acknowledge a lot of people. So, I'm just gonna read these real fast. Our Cesar Clayburgh Wildlife Research Institute faculty and staff, East Foundation, the various groups that have funded this project, the many professors that have assisted with us. We have a wonderful prescribed burn crew that is currently out in 94-degree weather right now burning without me. Our wonderful field crew and volunteers. And with that, I think I caught us up. We have time for questions if anybody has any, so thank you.